let's review the basics of the simple planetary gear set. So let's go over the difference between a drive gear and a driven gear. Every gear set needs a driving and a driven gear. And so we do that by the gear size, and typically we use the number of teeth to determine that gear size. Now, anytime we have a small gear driving a much bigger gear, we're going to have a gear reduction, or also something known as underdrive. That means this drive gear is going to go around 2 times for every 1 turn of that driven gear, and we're going to get a speed and torque change. When we go into an overdrive, then we have something like a 0.5 to 1 gear ratio. Now that means the drive gear is larger than the driven gear. And in this example, this drive gear goes around a half a turn, or 0.5 to 1 turn of that driven gear. Now if we have gears that are the same size, we call that direct drive, because for every 1 turn you have of the drive gear, you'll have 1 turn of the driven gear. So there's no torque change or speed change taking place when you have a 1-to-1 gear ratio or direct drive. Now a simple planetary gear set simply consists of a sun gear, which sits right here in the middle. Then you have a carrier gear, but the carrier gear is made up of several pinion gears, and they're all connected together by this cage or carrier assembly. So this whole thing is called the carrier gear. Now the carrier gear can have 3, 4, or even 5 pinion gears. The last part of this is the ring gear, and that's on the outside here. This is a gear that has teeth that point inward, and it's often called an annulus gear. Now we have some gear rules that we have to go over so that you understand how this works. Whether it's in underdrive or you're in overdrive, you have to have 1 drive input gear and 1 driven output gear, as well as 1 gear that acts as a reaction gear. Now the reaction gear is typically a gear that is held stationary. However, that gear can also be a gear that's turning much slower than the drive input gear. When we have a direct drive circumstance, you're going to take 2 gears and you're going to drive those at the same speed. So you're going to have 2 drive input gears and 1 driven output gear, and you will not have any reaction gear. So let me try to explain this reaction gear thing. A reaction gear or reaction member is just simply an object that we use to push off of. So that gear has to have something to push against. Now an easy way to think about that is when you're walking down the street or you're walking in your house. Well, your feet push against the stationary floor, and that helps propel you forward. Well, that floor is your reaction member. It gives you something to push against. Now, that reaction member does not have to be 100% stationary. Think of a time when you walked through an airport and there was a moving walkway. Now, the moving walkway was still going in the same direction that you were walking. However, it impacted your forward progress. So the speed of that walkway alters your direction proportionally. Now let's look at some planetary gear rules. So with our planetary gear rules, it'll help us determine the rotation of each object. So the first gear rule here has to do with the sun gear and those planet pinions. Now, I'm not talking about the carrier, I'm talking about the planet pinions that are part of the carrier. The sun gear and the planet pinions will always rotate in opposite directions. Keep that in mind as we go through the rotational operation of a simple gear set. Now the ring gear and the planet pinions, well, they do something a little bit different. The ring gear and the planet pinions, they always rotate in the same direction. So keep that in mind. Now, the direction of the drive and input and the drive output are directly related to what we do with that carrier. If that carrier is reactionary, meaning we're holding it or we're turning it much slower than the drive input, then the drive input and the driven output well, they're going to rotate in opposite directions. This is how we get reverse. Just hold that carrier and the input and outputs go opposite directions. Now the last part has to do if the carrier is not being held. So the carrier is not being held, it's not reactionary. Now the drive and the driven, well, they're going to rotate in the same direction. So that would be for some sort of a forward-moving vehicle. Now let's take a look at an operational planetary gear set. Now in this example right here, we are taking and we're driving this sun gear and we're driving that clockwise. Now you can see how rule number 1 is applying because these pinions are rotating in counterclockwise direction. And rule number 2 that shows that the pinions and the ring gear rotate in the same direction. And here we're seeing that happening. The rule number 3 is also in play here. And rule number 3 says that if you hold this carrier stationary, then the drive input, turning clockwise, and the driven output, the ring gear, will turn in opposite directions. Now in this example, I have a carrier gear that is not being held stationary. So this is that rule number 4, and we are holding this ring gear stationary. And now we see that this sun gear, which is the drive input turning clockwise, is causing this carrier mechanism to also turn clockwise. And finally, when we get into a direct drive circumstance, no planetary gear action is happening because what we're doing here is we're driving the ring gear clockwise and we're driving that sun gear clockwise and we're driving them together at the same speed. And that's causing this carrier mechanism to rotate as one solid unit, so everything turns together in a 1-to-1 gear ratio. Let's now apply our understanding of gear sizes. Now we're going to take a look at the different gears, and here we have the sun gear, and the sun gear is going to represent the smallest size gear that we have. The ring gear represents a medium-sized gear, and I know it's the biggest gear that goes around it. Physically, it looks bigger, but it's considered the medium-sized gear. And that carrier gear is actually considered the large gear. Now, the way we get the carrier gear size is we have to add the sun gear and the ring gear together. We can't simply just add up the number of teeth on the pinion gears, because sometimes they have 3 pinions, 4 pinions, and 5 pinions. Now in this example, if the sun gear has 10 teeth and the ring gear has 30 teeth, then the carrier gear would have 40 teeth, and we could use that to calculate our gear ratio. This is again where we're going to apply the small driving a large is going to give us torque, and a large driving a small is going to give us a speed or an overdrive. So if we take a look at that knowledge now, if we have a sun gear that's the drive gear, so that is our small gear, and then we have a reaction member, which is the ring gear, which is your medium-sized gear, that's going to produce a driven output to the carrier, and that carrier is our large gear. Now we have a small driving a large. That means we're going to have a gear reduction or an underdrive, and we're going to have an increase in torque and a decrease in output speed.